x to the fourth, well, we know I to the fourth is just 1, so we're able to find just x to the fourth over 4 factorial, just that by itself. And now plus we have x to the fifth over 5 factorial. Well, it's really ix, quantity to the fifth. And we know I to the fifth is equal to I. So it's I, x to the fifth, over 5 factorial. And next we have to the 6th power, right? And I to the 6th is negative 1. It's just going to be minus x to the 6th over 6 factorial. And now x to the 7th, we get another minus. Actually, we're actually going to get minus ix to the 7th over 7 factorial. And for x to the 8th, well, I to the 8th power, that's just 1, because 8 is a multiple of 4. So then we get x to the 8th over 8 factorial, and of course, you know, it goes on forever, it's an infinite sum. But this is a proper number of terms for us to understand what this simplifies down to. So because in the group we're using, addition is both associative and commutative, we can rearrange all these terms into two distinct categories, basically. And you might know already, hopefully you probably know already that, well, you probably know already that these terms resemble the same terms that we've seen in the expansion of sine and cosine, which is very, very, very good thing to notice, very important. So what we can do, we can say, let's take every other term. I think that's a good idea. That'll help us out, because if you consider it, for sine and cosine, or for the sine function, we used odd exponents, wasn't it? Yes, we did. We have 1, and then, well, this is actually cosine. I'm talking about sine. So we say 1 is the exponent here, then 3, 5, 7, 9. So that's, you know, alternating, we can think of it as. So we have 1, and then, so I'm going to take this one, then this one. So I guess I'll start with the even ones for now, the even terms. So 1, and then if we have negative 1 times x squared over 2 factorial, that's minus x squared over 2 factorial. And we have a plus x to the 4th over 4 factorial, that's a nice even one. And this coefficient is minus, keep that in mind, that's minus x to the 6th over 6 factorial, plus x to the 8th over 8 factorial. And this is actually an infinite sum in itself, this whole quantity, because we're taking every other term, and every other term of an infinite series is an infinite sequence in itself. And so that's, you know, that's basically 1/2 of our equation. The other half, I'm about to sum up, and we have ix plus, well, this is actually minus, excuse me, minus I x to the 3rd over 3 factorial, and then we get plus I x to the 5th over 5 factorial. So each of these terms we're noticing has an I in it, minus I x to the 7th over 7 factorial, and that's, once again, infinite sum. And all that we set equal to e to the ix. And now comes arguably the best part. So we can substitute for this whole quantity transcendental function cosine of x. Because we've seen before, on this sheet, for example, that cosine has those even exponents we've seen, right? It goes 0, 2, 4, 6, and then we see that same alternating sign. It goes from +1 to minus to plus to minus. And that's what we're seeing here, the same exact thing. We have even exponents starting with 0. Anything to the 0 power is just 1. Then 2, 4, 6, 8, 10, etc., etc. And then that alternating sign. It's the same exact expression. So we're substituting cosine x for that. And we say plus. In this case, you'll probably recognize it is the same thing we've seen earlier, right here. So this is really equal to this, which I'm underlining, because we see ix and an ix here, minus ix cubed over 3 factorial, that's exactly what's here, plus ix to the 5th, that's supposed to be a 5, sorry about that, over 5 factorial, and that's the one that's here, and then we have that alternating sign, we have that same exact pattern. So what we're going to do, we can use the same tactic we said right here, factor out the I, and say it's really I times the sine of x. And so now we've shrunk down a somewhat massive infinite sum into something very tangible and useful. So e to the ix, we have just proven, is equal to cosine of x plus I sine of x. Now in the next section, we'll actually use this formula, substitute in some values, see what we get. And it'll be truly wonderful, so please join me.